Welcome to day 1 of our 5-day summer boot camp on Are You Ready for Calculus? I'm Eddie. I'm here with your first lesson of 5 lessons in this series. Whether you're in Algebra 1, Geometry, Algebra 2, Pre-Calculus, or maybe you're already in AP Calculus looking to solidify your foundational knowledge, you've come to the right spot. The number one thing that I teach very first to my students who think they're ready for AP Calculus is, do you have clear handwriting? If you need practice on this, just take a piece of grid paper, print it out from Google Images, wherever you can find, and start just writing stuff down like this and solve it straight down. Make sure the equal sign is right there, and you can say x is equal to 2/3, something like this, and it will help you write neatly. Square roots, you can do something like this and say x squared plus 3, anything like that. You can really write anything. You can start graphing things as neatly as you can, label your axes, right? Anything like this. Whatever works, clear handwriting is key. It can be the difference between earning and losing points on the AP exam. That's how important clear handwriting is. So that's the first thing that I cover with my students. Second, solving for x should be straightforward. I have 6 problems on here. You can pause the video and try them out yourself before I solve. I'll be getting started in 3, 2, 1. Let's get it. The fastest way to do this is not to multiply both sides by 4. The first thing I'm going to do is I'm going to cancel when possible. Then I multiply both sides by 2. I get 16. So now I have x squared plus 2x plus 1 is equal to 16. By the way, being mindful of my handwriting, I'm going to subtract 16 on both sides. Now I have x squared plus 2x minus 15. This simply factors into x plus 5 times x minus 3 is equal to 0. So x can be -5 or +3. There we go. Next, this time 3 and 4 do not cancel. So I'm going to go ahead and multiply both sides by the reciprocal of that fraction. So 4/3. And I do this to save steps. And it makes sense. When you multiply a fraction by its reciprocal, everything cancels out. 15 divided by 3 is 5. Therefore, we have 20 on this side and x squared minus 16. 2 ways to go about this. You can create a difference of squares on the left, or you can simply solve for x, isolate it. And don't forget, whenever we take the square root of both sides, we get either the positive or negative version of that solution. Same idea here, multiply by the reciprocal of the fraction that you see. So 5s cancel, 3s cancel, leaving just 1s. This gives us 10/3, and we have 2x squared minus 3x minus 2. Well, I'm going to go ahead and subtract 10/3 on both sides. But before I do that, I'm actually going to go ahead and multiply everything out by 3, so I don't have to work with this fraction. So I get 6x squared minus 9x minus 6 is equal to 10. So I get 6x squared minus 9x minus 16 is equal to 0. From here, I do not know if this will factor well. Let's see if I can figure something out here. I don't believe it will, so I'm going to go ahead and use the quadratic formula. Handy dandy quadratic formula goes -b plus or minus the square root of b squared minus 4ac all over 2a. So x is equal to 9 plus or minus the square root of 81. 4 times 16 is 64, times 6 will be 384, so we have plus 384. You can check my math there. That's 12. 81 plus 384, that gives us 465. I don't believe that is a perfect square, but it is divisible by 5, and we get 93 after, then 3 times 31. So this does not have any factors that are perfect squares over 12. We can leave it like that. You can go a little bit more, say 9/12 is 3 over 4 as well, but I would prefer you just leave it like this. And actually, in AP Calculus, if you left your answer like this on a free response question, this very first fraction, you would get full credit. So I would actually tell my AP Calculus students to stop right there. Especially on the no calculator section, you do not have to simplify any further. And if you were on the calculator section, you would simply plug that into your calculator. Let's check this one out. X squared plus 2x plus 1, that's just x plus 1 squared. And on the bottom, we have a difference of 2 squares. Notice how the x plus 1's cancel. So we actually have something called a removable discontinuity at x equals -1. So one of these cancels out, leaving us with x plus 1 over x minus 1 is equal to 3. I'm going to go ahead and multiply both sides by x minus 1 with a condition that x cannot be 1 or -1. So now I have 3x minus 3 equals x plus 1. So 2x will equal 4, and x is equal to 2. Boom. This next one is a little tricky, because if you notice, the bottom has a square root, but the top doesn't. And the top kind of looks like a difference of squares, and it is, but not many students are able to recognize it at first. So reminder, I haven't said this yet this lesson, but a good mathematician, whenever they are given a problem, pauses, observes, and looks for a pattern. X squared minus 5 is definitely a difference of squares. X minus radical 5 times x plus radical 5. So x plus radical 5's cancel. We're going to state the condition that x cannot be the square root of -5. So now x minus radical 5 is equal to 2, and x equals to 2 radical plus radical 5, and there we have it. Similar idea here. We'll have 2x and x. We'll have a minus 3 and then a plus 1 all over x minus 3, and that's equal to 4/3. The x minus 3's cancel, so my condition will be x cannot be 3. And so 2x plus 1 is equal to 4/3. 4/3 minus 1 is 1/3, and divided by 2 will give us 1/6. That's not 3, so we're good to go. Solving for x, you need to be able to do it effectively, efficiently. Pythagorean theorem, distance, slope, and AROC, standing for average rate of change, all essential. One of the very first things you're going to be dealing with, all 4 of these, in your first month in AP Calculus. Find the values of the unknown variables. Our 30, 60, 90 triangle ratios are really important to remember. If we have the shortest side, we can multiply by radical 2 to get to, multiply by 2 to get to the hypotenuse, and multiply by radical 3 to get to the longer leg. For a 45, 45, 90 triangle, if we have the hypotenuse, we can divide by radical 2 to get to any of the 2 leg lengths. Going in reverse, then, we would multiply by radical 2. Know your ratios for these special right triangles. Special right triangles is what you would want to search up. I also have a video on my channel for everything you need to know about triangles on the SAT, and that covers all the special right triangles, Pythagorean triples, Pythagorean theorem, all that as well. Find the distance and slope between each pair of points. All right, well, distance and Pythagorean theorem are actually the same thing, right? If you look at the Pythagorean theorem, a squared plus b squared is equal to c squared. That's basically the same thing as some distance. Take the square root of both sides, and we have the change in x squared plus the change in y squared. So what's the change in x? -5 to 1. That change is 6. So we have 6 squared plus 11 to -3. What's the change there? What's the difference there? That's 14. So 14 squared. That's our distance. 36 plus 196. That'll give you 232. So we have the square root of 232. Now, is this divisible by a perfect square? Absolutely. It's divisible by 4 to start. 4 times 58. And 58 is 29 times 2. So we have 2 radical 58. Now the slope, slightly different. We have the change in y over the change in x. Notice those similarities. We're constantly working with changes, deltas. Deltas, later on in AP Calculus, we will just call dx or dy and things like that later on. So that's why we're working with this so much right now, and why you've worked with it ever since 5th grade, 6th grade, pre-algebra, all that math. The changes in y's, we need to make sure to maintain the balance. So we're going to start with our second point, -3 minus 11, all over 1 minus -5. We get -14 over 6, which is -7 over 3. We're going to do the same idea with this blue one. The distance will be the square root of the change in x squared plus the change in y squared. Negative 3 to 1 is a change of 4, and negative 4 to 3 is a change of 7. Y'all, it's really that simple. We get 16 plus 49. That's the square root of 65. Now for slope, the second point minus the first point is basically what we're doing. Change in y over the change in x. So we get 7 over 4. Voila. That's all there is to it. The unit circle. I want you to take some time to practice the unit circle. I'm going to put all the components of the unit circle that we know on here so that you can practice as well. I'm going to start with my quadrants. I know that every point up here in the first quadrant is going to be positive, positive. Here it's going to be negative, positive, negative, negative, and positive, negative. For my degree measures, pretty straightforward. We go from 0 degrees to 360. We go 30 degrees, 45 degrees, 60 degrees, 90 degrees, 120. You can skip this part of the video if you're already comfortable with the unit circle, but I'm basically going by 30s and 45s. And after I go all the way around in degrees, I'm going to go ahead and go around in radians. And I'll do this in a different way so that you can see where I'm getting these numbers from. 0 and 2 pi. Why is it called the unit circle? Because the radius of this circle is 1. So then the circumference of this circle, 2 pi r, will be 2 pi times 1, which is 2 pi. Split that in half, get pi. Split pi in half, that's pi over 2. Split that in half, you get pi over 4. But what if we split pi over 2 into thirds? Then we get pi over 6, then 2 pi over 6, which is pi over 3. And then using that same pattern, we can figure out the remainder of the unit circle. So these are what we call radian measures. A radian, you can kind of think about as a radius angle. So if you look at the term radian, you can notice it's basically two words put together, radius and angle put together. Now, last but not least, we have our coordinate points from our special right triangles, the 30, 60, 90 triangles, and the 45, 45, 90 triangles. We're starting with 1, 0 here, by the way. We have 1/2, radical 3 over 2, and we're just going to go all the way around here. No skipping steps. I want you to practice this as much as you can, because there will come a time, and I guarantee it, that you will need this. You will need this simple calculation, this simple pattern recognition on the AP exam, whether it might be that's a 1, by the way, -1. I'm so locked in right now. Super locked in. And there we have it. Just like that. All students take calculus. Everything is positive in the first quadrant. The sine is positive in the second quadrant. Tangent is positive in the third quadrant. And cosine is positive in the fourth quadrant. Last but not least, trigonometric identities. We must be quick with these. Sine of theta times secant of theta. Well, secant is 1 over cosine theta. Sine is just sine. When we multiply these together, we get sine theta over cosine theta, which is simply tangent theta. We want to simplify each of the following terms into single term. Secant is 1 over cosine. And now cosecant is 1 over sine. But when we divide by something, we can multiply by its reciprocal. So technically here we have sine of x over cosine of x. And guess what? We get tangent of x once again. Cosine of theta times 1 plus sine of theta. So this is a Pythagorean identity. This is actually secant squared theta. Cosine and secant are reciprocals, and they're both squared, so they cancel out, and we're just left with uno. Down here, I have 1 plus cosine of y. These are really neat once you see the beauty in them and the patterns. They're just so beautiful. I'm going to go ahead and multiply this 1 by a cosine of y, cozy over cozy, because I want common denominators. So now in the full denominator, I will have cosine of y plus 1 all over cosine of y. But remember what we said up here. When we divide by something, we can multiply by its reciprocal. So if I rewrite this, I have 1 plus cosine of y times cosine of y over cosine of y plus 1. Guess what happens? These go poof in the night. I get cosine of y as my final answer. Tangent of t. When in doubt, rewrite them as your reciprocal or as their equivalent ratios. And something really neat happens here. Everything cancels out. So we're just left with uno. Know your negative and positive theta trigonometric identities as well. Tangent of theta plus cosine of negative theta is actually the same as cosine of positive theta, and this is represented in the unit circle. If you take cosine of negative 30 degrees, that's my x value, and the cosine of positive 30 degrees, that's my x value. They are the same. But when we take tangent, tangent involves the sine value in the numerator, so this is actually just equal to negative tangent of theta. If we rewrote all this, notice how the tangents will go poof in the night, and we're just left with cosine of theta. Verifying your following trigonometric identities is also very, very important. Let's take a look at this one. We're going to keep the right-hand side the same, and we're going to manipulate the left-hand side. So I have cosine of x times secant of x. These cancel. That's just 1 over tangent of x. And guess what 1 over tangent is? That is the reciprocal for cotangent. Great. We write QED. Quod erat. Oh, I forgot what the D stands for here. Demonstratum. That for which was to be demonstrated. Something like that in Latin or Greek or something like that. We're going to keep the right side the same here. Play around with the left side. Tangent is sine theta over cosine theta. This one is quite beautiful. Hopefully you can figure this one out as well. Sine theta. We want a common denominator. So I'm going to go ahead and multiply both top and bottom of this left one by cosine of theta. Oops, sine of theta, sorry. Sine of theta over sine of theta. And this right one by cosine of theta over cosine of theta. Guess what happens? On the top, I get sine squared theta plus cosine squared theta. And on the bottom, I get sine theta, cosine theta. This is quite beautiful because this is what I call the OG Pythagorean identity. All this is just equal to 1. So now we have 1 over sine theta times 1 over cosine theta, which is cosecant theta times secant theta. We can just rewrite it as such because multiplication is commutative, QED. If you enjoyed this and found this helpful, or it was just building some confidence for you, make sure to subscribe, like if it deserved it, and comment down below if you have any questions about what's to come in the following sessions. Reminder, this is just lesson 1 of the 5-lesson series on Are You Ready for AP Calculus? I have a course as well. You can check out the link in my bio. I'm teaching AP Calculus next academic year starting this summer. So that's very, very exciting. I will see you all next time for day 2 out of 5 of our Are You Ready for AP Calculus series. See you soon.